All right, lesson 5, we calculated what the standard deviation was, which we also looked in your calculator. Looked like that. We can calculate it by hand or we can use our calculator, it's up to you. Today we're going to interpret what that means. So example 1, your teacher will show you how to use a calculator, which we did in class the other day, to find the mean and the standard deviation for the following set of data. A set of 8 men have heights in inches as shown below. Indicate the mean and standard deviation you obtained from your calculator to the nearest hundredth. Pause. I need to do that. All right, there we go. That's what I got. I didn't round correctly with the mean, so I fixed that. And then I found my standard deviation. Exercise 1. We're going to practice the mean and standard deviation again. So we've got the height in inches of 9 women shown below. So go ahead and calculate it again using your calculator. Again, if you're not sure how to do this, you need to see me and we will definitely figure it out. Okay, pause. There you go. That should be pretty good. And again, I need you to see me on your own to learn how to use your statistics function on your graphing calculator. If you haven't purchased a graphing calculator yet, you need to see me again and figure that out, or head to your nearest Walmart and pick one up. All right, exploratory challenges. A group of people attended a talk at a conference. At the end of the talk, 10 of the attendees were given a questionnaire that consisted of 4 questions. The questions were optional, so it was possible that some attendees might answer none of the questions, while others might answer 1, 2, 3, or all 4 of the questions. If so, the possible numbers of questions answered are 0, 1, 2, 3, and 4. Suppose that the number of questions answered by each of the 10 people were shown in the dot plot below. Use statistical feature on your calculator to find the mean and the standard deviation of the data set. Just so you know, what I'm typing into my calculator this time are the numbers 0, 1, 1, 2, 2, 2, 2, 3, 3, and 4. Okay, so go ahead and try that and see what the mean and standard deviation are. I have a mean of 2 questions and a standard deviation of 1.15 questions. Okay, so let's analyze that. What does it mean? Okay, what if the dot plot looked like this? The mean and the standard deviation I just did. I've got 2 questions for the mean, and the standard deviation was 1.49, a little higher. And you can notice the difference here. This is flat across, where the previous dot plot was very symmetrical, right? Remember that the size of the standard deviation is related to the size of the deviations from the mean. So the size of the standard deviation is related to the size of the deviations from the mean. Explain why the standard deviation of this distribution is greater than the standard deviation in exercise 2. I just sort of did. Let's see. For exercise 2, we had a mound-shaped distribution. I mean, it looked very much like this. And then for exercise 3, it was very uniform. Everything looked like that, straight line across. Okay, so there's your reasoning. Number 4, suppose that all 10 people questioned all 4 people that were questioned answered all 4 questions in the questionnaire. What would the dot plot look like? So all 10 people answered all 4 questions. My dot plot would look very interesting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What is the mean of the questions answered? 4. Right? I didn't have to calculate that one at all. Okay, I just looked at it. I could add all those up and divide by the number of people, and I would get 4. What is the standard deviation? I shouldn't need a calculator either. My standard deviation is actually 0 because there were no deviations from the mean. If my mean is 4, the distance from the data points to my mean is actually 0 this time. Continue to think about the situation previously described where the number of questions answered by each of the 10 people was recorded. Draw the dot plot of the distribution of all possible data values that has the largest possible standard deviation. There were 10 people at the top, so there should be 10 dots on your plot. Use the scale given below. Largest possible standard deviation would mean that the dots are far apart from each other. Right? The distance from the mean to the data is the furthest. So if I had a mean of 2, I could have, sorry, that is just 1. Oh goodness. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. If I calculated the mean of this, the mean would be 2, and the standard deviation would also be 2. So the distance from here to there is 2, and the mean, which is the average, would also be 2. The standard deviation of this distribution is larger than that of the one in exercise 4 because deviations from the mean here are all greater or equal to the deviations from the mean in 4. Okay? Oh my goodness, that's it. What a great lesson. It's tiny. The mean and the standard deviation of a data set can be found directly using statistical features of your calculator. The size of the standard deviation is related to the sizes of the deviations from the mean. Therefore, the standard deviation is minimized when all the numbers in the data set are the same and is maximized when the deviations from the mean are as large as possible. So when we had all the dots on top of each other, the standard deviation was the smallest. When we were rounded, I guess that would be the middle. And then when they were the furthest apart, that was the largest standard deviation, right? Nice job. All done.